Brent Brockerville. You may know me as Brent Brockerville. Let me ask you something. Have you ever wondered how space shuttles fly? Well, if you have, you're in luck, because in this video, you'll get exactly what you're looking for. And if you haven't ever wondered, well, you're being forced to watch this video anyway, so why not just enjoy the ride?
A space shuttle system is the most complex and technologically advanced machine in the world. It's often referred to as a STS, Space Transportation System, and consists of three main components: an orbiter, propulsion systems, and an external fuel tank. In the 1970s, the United States National Aeronautics and Space Administration, NASA, created the shuttle to serve as a reusable space vehicle good enough to perform 100 missions with only minor maintenance. It took 10 years of preparation, but on April 12, 1981, the first space shuttle, Columbia, was launched. Today, NASA's fleet of space shuttles includes Discovery, Atlantis, and Endeavour.
Basically, the space shuttle was designed to transport human cargo to and from orbit around the Earth. During the first stages of liftoff, the shuttle leaves Earth vertically strapped to a launch rocket. The launch rocket provides most of the thrust power needed to lift the space shuttle into orbit. The rest comes from the shuttle's main engines. Once the mission is completed, the shuttle returns to Earth in a horizontal position and glides to land on a conventional runway. That's right, Patrick, in a horizontal position.
Now let's talk about shuttle structure. First up, the orbiter. The orbiter can be thought of as both the brains and heart of the STS. All of the latest advances in flight control, thermal protection, and liquid rocket propulsion can be found on the orbiter. The three major components of the orbiter are the pressurized crew compartment, the huge cargo bay, and the three main engines mounted on its rear. The orbiter's underbelly, bottom of the wings, and other heat-bearing surfaces are protected by a thermal protection system, or TPS. Today the surfaces of the orbiter are covered with silicate fiber tiles, which are designed to be used for 100 missions before requiring replacement.
You know, there are about 24,000 individual tiles that must be installed on the orbiter's surfaces by hand. These tiles are incredibly lightweight and about as dense as balsa wood. These tiles can dissipate heat so quickly that a white-hot tile with a temperature of 2300 degrees Fahrenheit can be held in bare hands following its removal from an oven. Smells good.
Alright, now let's talk about the propulsion systems.
The thrust required to lift the orbiter off the ground for the initial climb and fly the shuttle into orbit is provided by the propulsion systems. These propulsion systems consist of the two solid rocket boosters and the three space shuttle main engines. Now, think of the thrust like this. This elastic band is going to be our solid rocket boosters that's going to provide the thrust to our paper rocket. So, thrust is going to provide our paper rocket with a temporary boost of flight time. So, let's try it out. Woo! Look at that thing fly. So you see, that's how thrust works.
The main engines operate for the duration of the shuttle's powered flight, which is approximately 8.5 minutes after launch. Thrust is developed by the main engines in a staged combustion cycle, which uses high-energy liquid propellants. These engines, clustered at the rear end of the orbiter, are designed to work for 55 flights and have a combined thrust of approximately 5.3 million newtons. The main engines continue to provide thrust after the solid rockets are discarded. This stage accelerates the shuttle an additional 14,000 miles per hour in just 6 minutes to reach orbit. Liquid hydrogen and liquid oxygen make up the liquid propellant burned by the engines. The liquid propellant is composed at a liquid oxygen-liquid hydrogen mixture ratio of 6:1. On average, the engines burn 500,000 gallons of liquid propellant as the shuttle accelerates. The exhaust produced by the engines is mainly water vapor because of the combined hydrogen and oxygen.
You know, the liquid fuel is used at a rate that would drain your average family swimming pool in under 25 seconds, generating over 37 million horsepower. That's a whole lot of hay.
For the first 2 minutes of flight, the solid rocket boosters, or SRBs, work in parallel with the main engines to provide the additional thrust needed for the orbiter to escape the gravitational pull of the Earth. The space shuttle is taken to an altitude of 45 kilometers and a speed of 3,094 miles per hour before the SRBs separate and fall back into the ocean. The SRBs provide about 26 million newtons of combined thrust power. During the initial climb, the SRBs also help in guiding the space shuttle. The SRBs are composed of the solid rocket motor, along with the structural, thrust vector control, separation, recovery, and electrical and instrumentation subsystems. The solid rocket motor contains a segmented motor case loaded with solid propellants, an ignition system, a movable nozzle, and the necessary instrumentation and integration hardware. There is more than 450,000 kilograms of propellant contained in each solid rocket motor. Powdered aluminum mixed with oxygen provided by a chemical called ammonium perchlorate is actually the solid fuel.
Once the space shuttle's main engine shut down, as the ship approaches the altitude where it will begin orbiting the Earth, another propulsion system will take over. The thrust required for major orbital changes is provided by two orbital maneuvering system engines, which are located on either side of the aft fuselage. There are also 44 small rocket engines, known as the reaction control system, which are used for more precise maneuvers in orbit. These engines are clustered on the shuttle's nose and on either side of the tail. For the shuttle's important tasks of retrieving, launching, and repairing satellites in orbit, these engines have proven an essential system. Darn it!
Lägg av!
Sure.
Now, buddy.
Oh mince! Damn it!
Manage!
Jag kan signa! Damp nochmal!
Droge. Inte way. Det var negativt.
गुड़ नाल विश का मिठा हो सर जी तो आई छती 1 मिनट देखी.
Learn for free at the world's largest poker school, partypoker.net. Everyone's playing.